Hello, everyone. End this presentation by just inviting everyone to this simple exercise. So first, what I want you to do is I want you to close your eyes for a second. Are you with me? Now I want you to just imagine all of your personal information and secrets are all safe and secure. Now open your eyes. Could you imagine it? No, me neither. Unfortunately, we just don't really live in this world right now. That's why I'm here to talk to you about machine learning for detecting sensitive documents on SharePoint. One sec. All right. So before I jump in, just gonna want to give a quick introduction to myself. So I'm Wilson Tang. I go by he, they pronouns, and I'm a second generation Asian American. I just want to mention that because I wouldn't be here where I am today, sitting on this podium in front of me, or standing, if it weren't for my parents immigrating here for a better life for our family. And yeah, in my current role at Adobe, I'm a machine learning engineer in threat hunting. And before that, I attained my master's degree in computer science from the University of Washington in 2022, where I specialized my studies in machine learning. And now in my role, I'm passionate about finding new ML applications in security. So I know there's been a lot of hype about ChatGPT. You might have heard about that. But I think now is the moment with all this hype building around. I think we can really take this opportunity to really think about all the things in machine learning, not just ChatGPT, but everything else, to see how we can really apply it to solve some of our security problems. And outside of security, some of my hobbies include cooking. I like cooking new foods. I'm a foodie, like to try new restaurants. Traveling, like to go to different countries and explore different cultures. And on my off time, like to play video games. The one I'm pretty into right now is Valorant. And yeah, that's a little bit about me. Hope that gives you a good picture of who I am for the rest of this talk. So I'm gonna give a basic overview of what I'm gonna go through in this talk. First, I'm gonna talk about document classification and how it kind of fits into this realm of sensitive documents. Then I'm gonna talk about how we define these sensitive documents in this project. And then I'm gonna talk about how, using that definition, how do we build machine learning models to detect these said documents? And finally, how do we deploy these machine learning models as an automated pipeline for real-time detection? And then I'm going to wrap up with noting some key challenges we faced during this project, and then also talking about some future projects we want to tackle based on this. So now let's jump into the meat of this talk. First, I want to define machine learning, and there are a lot of definitions of machine learning. This is the one I align with and agree with. You can say that machine learning is a category of artificial intelligence, or AI, where we use lots of data to train a model that can predict on some task. And on the diagram on the top right, this is a common depiction of what you might see machine learning is. So on the outer bubble, you have AI, and then machine learning is a subset of AI, and deep learning, which uses neural networks, is a subset of machine learning. But where we really want to apply this is with sensitive documents, it really falls under the problem of document classification within machine learning. And this problem is assigning a document with one or more categories. And the most common example you've probably felt in your everyday life is spam filtering. Like, how does your Outlook, how does your Gmail know if an email is spam or not? Classic example of document classification. And there are a lot of common techniques for document classification, such as like naive Bayes, expectation maximization, TF-IDF. I won't talk your ear off on all these techniques. You can go research them after this talk. But the one we're really going to focus on today is random forests. So how do we define sensitive documents in this project? And we define it by files containing any information that should not be shared broadly across the company, most commonly when access permissions are set incorrectly on these documents. So the first example I think of when I think of a sensitive document is a job offer. A job offer, you would really only want it contained within the HR department, the hiring manager, maybe even the candidate, and you wouldn't want this document to be exposed to everyone in the company because you don't want your privacy. You don't want everyone to know how much you're making or what you got offered. And a quote that I really like that highlights the importance of this is this from Dan O'Day from the Unit 42 IR report. Unauthorized acquisition of a single spreadsheet containing a list of individuals' PII could result in a large data breach, even though the file size itself may be very small. And I think this really highlights that these documents are small in nature, but they're at the utmost importance to really protect these so they don't get leaked and exposed to people who shouldn't be seeing these files. So now that we have this problem, at Adobe, large organizations and any org in general these days, we're relying on cloud documents to do our daily operations more and more. So as the scale of cloud documents increases, then how do we effectively scale in detecting these sensitive documents that really shouldn't be exposed to people who shouldn't see them? And the answer we're coming to here and what I'm going to address in this project is machine learning. Before we jump into the model, it's also really important in ML tasks to define our data very accurately. So in this project, we define sensitive documents in two key ways. The first one is sensitive documents, where whole documents are sensitive in nature. For example, I talk about job offers, that whole document is sensitive and you don't want that exposed. And the second one is documents with sensitive information. And these are documents that aren't necessarily sensitive in nature, but they can contain sensitive information. For example, API documentation, not sensitive, but they could accidentally contain an API key, and that makes it sensitive. Ooh, jump the slide too quick. So now I'm going to jump into the first type of sensitive documents that I define, which is the whole sensitive documents. And what I'm going to do here is I'm going to talk through how we go from the plain text raw document and go step by step through on how we get to the final prediction. So the first step here is that on the left, the left gray box, this is the plain text document that just has words on it. So this is a document with some informative and non-informative words. What we do first is an optimization step where we filter out non-informative words. And you might be asking what's informative, what's not. We define informative words as words that help us categorize whether a document is sensitive or not. For example, a document containing the word job offer, it might be sensitive, so that could tell us that it's a job offer. But words like this is you can say that these words are present in both sensitive and non-sensitive documents. So we want to filter those out, filter out the noise to make the model easier to train. So this we take the middle diagram where we filter out the non-informative words, and we're left with some subset of words. And then finally, with those words, we create a vector with counts of words. And this framework is commonly known as a bag of words. So if you look at the final vector we output, it has 1, 2, 2, 1, 1, 0, 0. And you can interpret this as the first one could be there's one word that's document, there's two sums, there's two informatives, and one job, one offer. And the zeros can be informative words that aren't present in this current document. So cool, now we have a numerical representation of a document. Now how do we take that vector and run it through our model and get a classification out of it? And from a very, very base level, what we're using in this project is decision trees. And what a decision tree is, it's a tree-like model that makes a prediction based on certain criteria and boundaries on that criteria. So if you look in this decision tree example, this is, I'm not a medical professional, but this helps highlight a risk for heart disease. So the first question we can ask is, oh, what's your age? And then if you're less than 18, then we can ask your weight, and then less or 60 kg can determine low or high risk, and then 18 to 30, and then more than 30. And you can see just by looking at this that this decision tree might suffers from overfitting. And overfitting is when you tune a model too well on training data, so it doesn't perform well on real world data. For example, you can see in the middle one, the 18 to 30, is there really no one 18 to 30 that's high risk of heart disease? Probably not. But why did the decision tree come up with this? Maybe because in the training data, there was no one 18 to 30 that had high risk heart disease. And so there are probably other factors that go into heart disease here, but this is how this decision tree learned low risk and high risk on how they chose to split on age first and then weight and then smoker. So you can see that the decision boundaries themselves, like the 1830, why is it 1830? Why isn't it a different range? Or why did you choose age first? These can lead to overfitting because that's really tuned to the training data, but not generalized well on real world data. But decision trees are a very classical approach to ML, and they can be very powerful. Given enough data, it might not overfit, but it is still very prone to overfitting. So how do we combat this overfitting so we can make it even stronger? One answer to this is random forest. And just by the name, you can see that we're going from one tree to a forest, which comprises of many trees. So a random forest classifier is where we train multiple decision trees and then average the decision across all trees. And how this helps reduce overfitting is by we're making sure each decision tree randomly chooses different decision boundaries and criteria on each level of the tree. So now we're going back to documents, but I can talk about like the next slide where maybe instead of choosing age at the top, maybe we choose it later in the tree. But now I'm just going to jump back to the documents example since we're talking about sense documents. So what we do here is that we have the document at the top, and then we feed it through these 5 different trees. And tree 1 might say, oh, 0.95, I have a 95% confidence that this is a sensitive document. Tree 2 says, oh, I have a 90% confidence. And then we add all those confidence up together, average them, and we get the final 0.95 score. And we can feel more confident about this number instead of one tree because we'll have multiple trees that have learned the data in different ways, so we can trust this number just a little more. And then finally, we add one more layer above the random forest where we create one versus all classifiers, where we train multiple models where each model is specialized at classifying one type of sensitive documents. So in the diagram here, you can see random forest 1 could be really good at classifying API documentation. The second random forest can be really good at job offers, and third one just another sensitive document type. And you can see in this example that we got a 95% confidence that this random forest thinks that this document is a job offer, while the other confidence was 30% and 5%. So what we do here, we just take the model with the highest confidence, and we say that the document is a job offer. And we chose this method it's an ensemble method. So where rather than having one multi-class classifier, we're having multiple binary classifiers. And we found this method better to easily train an accurate model. And this picture is our final model technique for detecting the whole sensitive documents. So you got the one versus all random forests, and the random forest contains trees in them. Cool. Now I'm going to talk about the second type of sensitive documents we talk about, which is documents with sensitive information. To remind you, that's API, for example, that's API documentation that might accidentally have API keys. And the way we approach this is through regex. And if you don't know what regex is, these are regular expressions, and it's just a language to help match patterns in the text. And what we did is that we did regex detection for both secrets and PII, and also how we implement is we use a combination of open source and internally curated regexes. And the example below, this is an example of a regex for an AWS API key, open sourced, and then below is an example AWS API key, and where you can see the correspond is in the red, the AKIA, that part matches to that segment in the regex, and the 16 characters matches the end of the matching on the right there. Cool. Now we have 2 modeling techniques to detect sensitive documents, machine learning and regex. Now how do we deploy these machine learning models, and how do we create an automated pipeline for real-time detection on them? So first, we start with the SharePoint API, where we query a number of files for a certain time period. And then with those files, we run them through our model. And then if our model detects if a document is sensitive, then we're going to directly alert our users through our user notifier app. And the user notifier app is going to prompt the user to respond, 1, this document is actually sensitive, I'll go lock it down. Or 2, this document is not sensitive, go improve your model. And what this does for us is that we store the responses back to our SIM, and then we can give it back to our model to establish a reliable feedback loop so we can continuously improve our model performance. And why I highlight this is because we can have really complicated algorithms and stuff with our machine learning models, but it's also really important to have innovative automation so we can make the use out of full use of our ML models. Yeah, that's our whole pipeline. Cool. Now I'm going to talk about some key challenges we faced while doing this project. And I believe these challenges also apply to any machine learning project you're trying to do in security. The first one is minimizing false positives. Why we care about this is because we definitely don't want to flood our analysts with a lot of alerts, a lot of false positives, and they'll experience alert fatigue. So the way we answered this is by using random forest. Random forests are less prone to false positives because of the nature of like you need these decisions and these decision boundaries to fit on the data. What you might get from random forests is you might get false negatives because, as we talked about, it might not generalize as well on the data. But for this particular use case with sensitive documents, within one company, you can imagine a job offer doesn't have much variation across the entire company. So in this particular project, in this use case, our random forest didn't have a high false negative rate either. So false positives, false negatives, all good. The second key challenge we face is a reliable feedback loop. And with the reliable feedback loop in security, it might be hard to get malicious and benign samples and also get real user responses into your training data. And how we answered this was using the user notifier app because this will allow us to automate recording responses from our users. And finally, some future projects where we hope to extend this is we want to implement more sophisticated ML models, such as we have random forests now. We also want to try out gradient boosted trees and also try out BERT models that are open sourced. And maybe we can try ChatGPT on it. Also, we want to expand the document category, so we have a set of sensitive documents that we're trying. We can definitely make that more broad, and we want to scan other cloud storages such as AWS S3 buckets, Azure Storage Blobs, and also GCP as well. Cool. If you miss anything in this presentation, or you just want to read it instead of listening to me talk, we also published this as a blog post on our Adobe Tech blog. It's called "Using Machine Learning to Help Detect Sensitive Information." Go check it out, give a like, give some engagement. It'll be really cool. And finally, I want to thank our team members that helped me on this project. It wouldn't have been possible without them. That would be Tiberu Borosh, Andre Stan, Kumar Vikramjit, and Joseph Davidson. And finally, I also want to thank BSides for hosting me today. It's been really fun getting to know everyone here. And as a side note, it's my first live conference, so it's been really cool to like see everyone and meet everyone's stories and everything. And finally, I have my LinkedIn QR code up here if you want to add me, connect. I definitely would love talking about. Yeah, go ahead. I'd love to talk about machine learning and security, what you think about it, and if you have any ideas, I'd love to brainstorm with you. And yeah, with that, I'll open it up to Q&A.
Thank you, Wilson. All right, if you have a question, please raise your hand and I will come to you.
I see one in the back up there.
Awesome.
Hello. Do you think this technology could ever potentially be used as a weapon to seek out sensitive documents over SharePoint and then report them back?
I think when you put it like that with any tool of detection, I think it could be used like maliciously like that. But I hope that for us, for our SharePoint, it should really only be internally accessible. Like there should be no way that like an outsider should be able to scan our own SharePoint environment. So for us, using this as an internal tool to scan our own SharePoint environment is the use case there. So yeah.
Any other questions? Next question is from the middle on your left.
Oh, and I say no way there, but like, there could always be a way, attackers, but just putting it out there. Yeah.
So how do you continuously refresh your data, the data that you train from? Like, in theory, if the company gets better, there's less sensitive information in the SharePoint. But like, how do you know, like, if your model isn't detecting something, it's because like there's less sensitive data versus like, the model isn't detecting something properly?
Yeah, that's a good question. I would think that even if the data is old, if we see that like same job offer pop up on the SharePoint, it wouldn't perform any less worse because it's able to detect it already. But I do get we might, if we're constantly improving, then like there would be less sensitive documents on the SharePoint. But I guess we also bring up another note. Maybe the documents change, and that's just common machine learning problem of just refreshing your data once in a while and making sure you have enough good samples to train on. But yeah, but if it's a document that like we've already know that is sensitive, then we should be able to always detect that no matter how much time has passed.
Other questions? Let's see a hand. I'm coming.
Yeah.
So in regards to random forest, you didn't discuss ensemble, the ability to combine the multiple configurations. So do you have anything you can say about that? Because I think that's a very important aspect of it.
Referring to this, sorry, just to clarify, referring to this part of the ensemble?
So, the ensemble is like it's being able to, combine multiple models, it's like a collection of models used rather than you have your single models and I see the trees, but like specifically, like if you have that model and then there's another one that can relate, combining the two models together.
I see. That particular use case, we haven't like necessarily explored like combining, like you're talking about like combining 1 and 2 together and their results, if I got that right.
Two separate. So
Oh, okay.
like you have a final model, so you have a model and then combining two models together.
Mm-mm.
So you have ensemble method, but you're using it as
Yeah.
So you have ensemble method, and you're using it. If you have one multi-class classifier, but you're doing it within one model.
Yeah, true.
So I'm talking about ensemble models, like putting models together.
Yeah.
And so it has that capability, and I just wasn't sure if you were going to discuss that.
Yeah. So that is basically with the ensemble method, then you would want to combine results of a multi-model, if I'm hearing that correctly. I guess the way we approached it is probably more simple than that. So instead of combining these results together, we do a max operation on them. So that's how I would interpret that. Yeah.
Last question up here on your left.
I'll make it quick. How well does the bag of words method generalize to source code documents?
To source code documents.
Does that make sense?
Yeah. Source code documents haven't necessarily explored to that because that's not necessarily what we see on SharePoint. But that would be interesting to see for me how that bag of words would perform. Yeah, that totally open to explore that. Yeah.
Awesome. Let's give one more round of applause for our presenter.